Okay, so in 11.5 we're going to talk about the volume of a pyramid. So remember, just like prisms, pyramids are identified by their bases. So when we do the volume equals 1/3 big BH, that is the only difference we have between each pyramid, because it's important that you know what the base is. So look down here, we have a triangular pyramid, the base is a triangle. Rectangular pyramid, hexagonal pyramid, heptagonal pyramid, and a decagonal pyramid. And if you look at these other diagrams, these show you different aspects of the pyramid. Make sure when you're identifying the height, it is perpendicular from the vertex down to the base. It is not the slant height, which is the height of one of the sides or faces of your pyramid. So those are all the things you kind of have to get in your mind. Also, this diagram just shows you that Cavalieri's principle applies to pyramids as well. Okay, so we're going to find the volume of a pyramid. This one happens to be the same as number 1 in your journal. So remember, we're going volume equals big B, 1/3, don't forget your 1/3, big BH. And so remember that you have to find your big B first. So the big B is 1/2 times the base times the height. Look for the 90 degrees on your base, not up here. That's signifying that this is the height. You want it the one that's on the base. So that gives you those measures. So the big B is 12, okay? And now we're going to go 1/3 times the big B, this is our volume, times 9. So this would be 1/3 of 12 is 4 times 9 is 36 meters cubed. So make sure that you look at all the different aspects. Keep this separate from your calculation here. Otherwise, that's where silly mistakes get made. People will forget the 1/2 because the 1/3 is there. So I always calculate my big B separately so I don't make that mistake. Okay, so here's a bunch of pyramids that we're going to calculate. So if you want to push pause and try these in your journal first, you are welcome to do that. And we will get going. So for this one, my big B is a rectangle, so it's length times width. So it's 6 times 6 is 36 inches squared. Now I'm going to identify the height of my pyramid. There's the height of my pyramid. I can see that it's perpendicular to the base. So my volume is 1/3 times my big B times 8. So that would be 12 times 8 is 96 inches cubed. Okay? Alrighty, over here we've got another, looks like a square because they're the same. So my big B is 16 inches or yards squared. This is a big one, yards squared. Okay? And then we find the height. I can see that it's a 90 degrees to the base. So there's my height. So I'm going to go volume equals 1/3 times 16 times 9. Now remember, commutative property is I can cross cancel the 1/3 and 9 real easy. So it's just 3 times 16 is 48 yards cubed. Okay, this one over here is a rectangular pyramid. So my big B is 7 times 11 or 77 meters squared. So now I'm going to multiply my volume is 1/3 times 77. Here's my height of my pyramid times 15. And so that one is 5 times 77. And the volume equals 385 meters cubed. Okay, and I keep telling you squared and cubed just to make sure you're understanding that as you do these out. Now, they were really nice here and they gave us the area of the base. So this one is pretty basic. 1/3 times 27 times 5 is 9 times 5 is 45 cubic centimeters. Okay, now over here this one is slanted, but notice that they gave you, and they actually should have drawn it better, this should be showing that it's a 90-degree angle. So they didn't give you that, but that's what they should show you. Otherwise, you have to assume it, and that's not a good thing. So our big B is 4 feet squared because it's 1 times 4. Okay, so we're going to go volume equals 1/3 times our big B times 6 is 8 feet cubed. And that's our volume of that one. So hopefully you followed along with that. But here's a really interesting problem that I'd like to work out. So we're going to use the volume to find the side length of the square base of this pyramid. So it says originally Khafre's pyramid had a height of 144 meters and a volume of about 2,218,800 cubic meters. Find the side length of the square base. So they told you right away that this was a square base, okay? And that the original height was 144 meters. Okay, we want to find this side length, one of those side lengths. So the fun thing to remember is that base equals side squared because it's a square. So now we're going to take the volume formula and we're going to plug in all the information we know. So 2,218,800 equals 1/3 times our big B, which we're thinking in the back of our head, that's side squared, times 144. The first thing I'm going to do is multiply both sides by 3 to get rid of my fraction. And I get 6,656,400 equals 144 side squared. I'm going to divide both sides by 144, and I get 46,225 equals side squared. Then I'm going to go ahead and take the square root of both sides, and I get 215 equals x. So that is the side length of the original was 215 meters squared. So it'd be kind of interesting to know what it is today. It looks like a whole section of this has fallen off, so that would definitely erode our side length. Okay. All right, so using the volume of a pyramid, find the height. So this one, they gave us the volume, and so we know that volume equals 1/3 big BH. So this time, we're looking for the height. So they gave us the volume as 14. Oh, but we have to calculate that big B. So the big B is 1/2 times the base times the height of the triangle, this height. Okay, so make sure you're being careful there. So it'd be big B equals 6. So 1/3 times 6 times the height, 14 equals 2h, h equals 7. So the height of this pyramid is 7 feet. Okay, so remember, when you're working backwards, it's helpful to find the base separate so you don't mix up the 1/2 and the 1/3. Okay, these are 3 problems from your journal, so I recommend you try them on your own. Otherwise, let's work them out. Okay, so for this one, it has a pyramid with a square base. So that means its volume equals 1/3 big BH, and the big B is side squared. So let's see what they want us to find. They want us to find the side length of the square base. So I'm going to set that equal to each other. The volume is 128. I have 1/3 times my big B times 6. So that's 128 equals 2B, and because 1/3 of 6, and then divide both sides by 2, my base equals 164. So since base equals side squared equals 64, that means my side is 8 inches. And there you go. Okay, so this one is a pyramid with a rectangular base. Okay, so I want you to think about these things as we're developing them. Okay, so this one, they gave you the length and width of your base, so that's cool. They gave you 3 and 1.5, and they gave you volume equals 6, but they did not give you the h. So that's what we're looking for this time. So I know that this one is volume equals 1/3 the big B, which is length times width, times height. So I'm going to set that all in here. So 6 equals 1/3 times 3 times 1.5 times h. So I just cancel these, and I said 6 equals 1.5 h, divide by 1.5, and I get h equals 4 feet. And there's the answer to that one. Okay? All right, this next one has a triangular base, and I'm going to draw it like this so that I can get away with something, and I'll show you in a minute. So, okay, so there is my triangular base, and I'm going to draw a line for my height of my pyramid, different color. Okay, so now we have a volume equals 1/3 the big B, which is 1/2 base times height. Notice there's small b, height, b and h for the area of a triangle, and then times the h of the pyramid. So now we're going to go 18 equals 1/3. They gave me the height of the triangular base, but they did not give me the base. So I'm going to go 1/2 times 3 times my base times the height of my pyramid, which is 9. So you can be really creative with this, but here's how I'm going to do it. So this 1/3 canceled this 3. And 1/2 of 6, or that's a b. So then I get 18 equals 1/2 times 9 times b. Okay, so that is, I'm going to multiply both sides. I'm going to divide both sides by 9. I get 2 equals 1/2 b multiplied by 2. This was kind of a roundabout way, but my answer is 4 centimeters is the width of the base. Okay, and you can always plug it back in to calculate and make sure that it's right. Okay, and I kind of did that convoluted. You could actually have done it a little simpler, but I just tried to have fun with it. Okay, so mathematically everything I did was correct. You might have done it in a different order. That's okay. Alrighty. So now we're going to talk about similar solids. We've already talked about that a couple times. So remember that the volume of the scale factor, is cubed. So notice that we have here, we have find the scale factor. So the first thing I have to find is the scale factor. So you look at the shapes, and we've got the height of pyramid B. So pyramid B is a height of 6. So we're just going to use the height. We have to compare it to the same linear measure as the other one. So that would be the A height. And that would be 8. So our scale factor is 3/4. Okay, so now in order to find K3, we go 3/4 cubed is 3 cubed over 4 cubed. So that would be 27 over 64. Okay, and then we're going to set that equal to our volumes. So they gave us the volume of A. A is on the bottom, so that would go here, 96. Okay, so then we would calculate that out. So we'd multiply, cross multiply, and divide, and we would get 64 volume B times volume B, which is x, that's our x, is volume B, equals 2,592. Divide both sides by 64. And the volume of B is approximately 40.5 meters cubed. Okay? So that's how you go about doing that. All right. So now let's try this one. You go ahead and push pause, try this in your journal, and then come back and let's work on it. Okay, so the first thing I want to find is the scale factor. So the scale factor of A to B is I use the height, 15 over 10, or 3 over 2. Okay, so now to find the volumes, I'm going to do A over B. So I'm going to say the volume of A is 125 over the volume of B, which I'm just going to call it the B, equals, and now I have to cube this. So that would be 3 times 3 times 3 is 27 over 8. So I'm going to set that up, 27 over 8. Okay, and now I'm going to cross multiply, and I get 27B, that's the volume of B, equals 1,000. So B is approximately 37 inches cubed. So we divide both sides by 27. So there you go. Okay, so remembering to cube the ratio, your scale factor, before you set it equal to this is crucial. Okay, so we're going to do one more kind of problem. Okay, so we're going to find the volume of this composite solid. And this is just putting together some of the things you've already learned. So the volume of the whole composite is the volume of the cube plus the volume of the rectangular pyramid. Okay, so first thing I'm going to do is find the volume of my cube, which is 6 cubed, because it's 6 times 6 times 6, length times width times height, and that is 216. Okay, and then I'm going to find the volume of this, which would be 1/3 times my base times our 6 times 6, so that'd be big B is 6 squared, times my height, which is 6, so that'd be 1/3 of 216, which would be 72. Okay, so that would be plus 72, and that equals 288 meters cubed. So that was a pretty easy problem, and that's how you do composites. Okay, so that's the end of this section. We're almost done, guys.